Hello, and welcome back to FlexSim Geek. Today, we're going to explore material handling with robots using FlexSim. So, let's get started. Open FlexSim and create a new model. In the Model Units window, make sure to set the units exactly as shown in the video. Next, I'll start by adding a shape to the 3D environment. I'll change the shape type to a box, and then resize it as needed. Now, I'll add a robot to the model. After that, I'll add a queue, change its shape to a box, and place it on top of the first shape. I'll also adjust its dimensions to fit properly. I'll rename the queue to Loading Lock. Next, I'll add a processor. Since I need 5 of them, I'll simply copy and paste the first one until I have all 5. Finally, I'll add 2 more robots to complete the setup. Now, we'll add a process flow to the queue to generate the inventory item. To do that, go to the process flow and add a blank Object ProcessFlow item. I'll rename it to Part Generation Process Flow. Next, I'll add a scheduled source and set the quantity to 1. Then, I'll assign a label named Tracker and also set its quantity to 1. Now, I'll add a decide activity and rename it to Check Queue Content. I'll set it to conditional decide, and for the condition, I'll use current.subnodes.length greater than 0. After that, I'll drop in a wait for event activity. I'll also add a breathe activity. In the wait for event activity, set the event to onExit. Then, loop it back to the decide activity, just like this. Now, I'll split the flow. On the other connection from the decide activity, drop in a create object activity. Rename it to create block, and change the assign in field to token.block. Okay, now I'll add a global table. I'll rename it to name to production sequence. I'll set the number of rows to 10 and the number of columns to 2. Next, in column 1, I'll rename the entries from block 1 to block 10, and in column 2, I'll set all the values to 25. Make sure to update the string format in column 1 so that the names reflect block 1 through block 10. Now, I'll add a label in the create block section. I'll assign the name as name and its value as a global table lookup. In the table section, I'll refer to table production sequence, and in the row section, I'll set the token to token.tracker and the column value to 1. Next, I'll add another label called non-processed wafer quantity. I'll set the row to token.tracker and the column to 2. Then, I'll create another variable called processed wafer quantity and set its initial value to 0. After that, I'll add a breathe activity, and just below the block, I'll insert a change visual activity. I'll rename this one to block color. Inside the change visual activity, I'll set it to color by case. In that section, I'll assign the object as token.block and the value as token.tracker. Once that's done, I'll add another assign label activity and rename it to increment tracker. Inside this activity, I'll set the label name to tracker, the value to increment label, and the increment value to 1. Next, I'll add a decide activity and rename it to check tracker value. Inside the decide activity, I'll set the condition type to conditional decide and use the condition token.tracker less than 10. After that, I'll connect these conditions to the first one, just like this, so that if the condition is true, the process will loop through. On the second connector, I'll add another assign label activity, name it set tracker value. And set its value to 1. Finally, after the assign label activity, I'll connect it to the initial decide activity, just like this. Make sure to connect everything exactly as shown in the video. After that, we can run the model to check if everything is working correctly so far. As you can see, the block is still being created on the loading dock, but it's slightly offset. So, we'll need to fix that. To do this, go to the queue properties and set the item placement to stack vertically. Now you can see that the block is perfectly aligned at the center of the loading location. That's all for part 1. In the next part, we'll dive into the General ProcessFlow, which is responsible for robot movement and material handling. I hope you gained some valuable insights from this video. See you in the next one.